Okay, so hello everyone. Today we will talk about my project on the responsibility AI for customer churn prediction. So this project is based on the IBM telco customer churn dataset, and the main goal was not only to predict whether a customer will churn, but also to study the model from the responsible AI perspective. So this project have four connected goals. So first is build a reliable churn predictions module, and the second one is explain how the module makes decision, and the third one is evaluate the fairness across different customer groups. So and the fourth one is turn the module result into useful retention um, ideas for the business. And I want to emphasize that one point at the beginning. A churn module is not truly useful if it only gives predictions. It should also be interpretable, fair, and actionable. And this is the main idea behind this project. And this dataset contains over 7,000 customer records and 21 variables. And these variables include customer demographics and service subscriptions and bill information and check outcome. During pre-processing, and I cleaned the data and handled the total charts field carefully. And after cleaning, the dataset had zero missing values. The overall churn rate was 26%, and so about one out of the four customers charged. And before the building any module, I first look at the data patterns. So early result already shows strong business signals. So for example, the customer with month-to-month contracts had a churn rate of 42% and was higher than the 11% for 1 year contract and only 2% for 2 years contracts. And I also found customers use fiber optic internet had very high churn at 41%, and for the customers paying with electronic check had the highest churn rate that's 45%, and the senior customers shows clearly higher churn than the non-senior customers. So even before the modeling, the data already suggests that the churn is strongly related to the contract structure and the payment method and the service type. To balance the performance and the interpretability, I used two modeling tracks. For classical machine learning, I trained the logistic regression, random forest, and the XGBoost. For deep learning, I trained the multiple perceptron or MLP. So I use train validation and the test split. I also applied preprocessing through the imputation and the standardization for numeric variables, and one hot encoding for the categorical variables. And to compare the modules, I focus on mainly on the ROC AOC on the validation set. This is important because churn prediction is not only about the overall accuracy. I also care about how well the module rank the high risk customers. And the most important result here is that logistic regression performs best overall among the classical modules, and the validation ROC AOC was 0.83, certainly better than the random forest and the XGBoost. So this result is meaningful and because it shows that for this structured dataset, a simpler module can still perform very well. So from the responsible AI perspective, so this is helpful because logistic regression is easier to explain and audit than more complex black box module. After module collections, so I turned the classification threshold, and instead of using the default threshold of 0.5, I selected the 0.61 based on the validation performance. And I did this because in churn problem. So threshold choice affects the balance between catching churn customers and reducing false alarms. And with the final setup, the test result detail of logistic regression module is on the slide. You can see it, and these results are strong and practical. The recall is especially important here. It means a module was able to identify a large share of the customers who were likely to churn. So I also tested the deep learning module, so MLP was competitive, especially on the recall and F1 score. And however, it did not clearly outperform as a final logistic regression model. So my conclusion is that this data set, the simpler classical module offers the best balance between the performance, stability, and interpretable. To understand the model behavior, I used sharp LAM and PDP with ice plots. This method helped me study both global patterns and individual predictions. So across these three methods, the most important churn drivers were very consistent, and the main variables were tenure, so contract type, internet service, and the support related features such as tech support and the online security. So this consistency is important, and it suggested the module is learning real business structures, not the random noises. So the interpretation is also very clear from the business point of view, and the customers with a shorter tenure are more likely to churn, and the customers with weaker contract commitment, especially month-to-month contracts, and also more likely to churn. So service and support configuration also matters. So the sharp results, line local explanations, and the PDP trends all points in the same directions. That gives more confidence that the module is making the meaningful decisions. And so this part is project shows the module is not only the predictive, so that also explainable in the way that business users can understand. In this slide, I focus on the fairness. So for gender, the result was pretty good. The gap was very small. So overall, the most module I looked balanced between the male and female customers. But for the senior citizen, the story is different. So the module predicts the churn much more often for senior customers, and the false positive rate was also much higher than this group. So this is important. It means modules works well overall, but it not equally fits for every group. So my conclusion is simple. So this module should be used to support decisions, not just make automatic decision by itself. So this slide is talk about the anomaly detections and what-if analysis. First, I used anomaly detections to find the Euro customers. About 3% of the customers were flagged as outliers, and interestingly, these outliers was not the highest churn risk group. So their churn rate is actually much lower than the rest of the data set. So in this case, being a euro did not mean being unstable. So then I did what if analysis for the one high risk customer, and the original churn probability was very high, about 0.96. And I tested the several possible changes. So small changes like adding the tech support or online security helping a little, but the biggest improvement come from the change the contract type. So the key message here is clear. So the strongest retention level was contract redesign, so not small service changes. Yes, the final logistic regression module performed well, but that's only one part of this project. The bigger result is now we know the why customers churn, and the main drivers were the tenure, contract length, and the service payment structure. And we also learn about an important fairness lesson. So the module looks balanced for the gender, but it shows a real concern from the senior customers. So this module should be used in the human review to reduce churn. The company should focus on the improving contract conversion, reducing payment frictions, and strengthen the support service for high-risk customers. And so overall, this is not just a prediction module, it's a responsible and more useful decision support tool.